Okay, so this is our final video with the wave function, and actually our final video with trig equations, which for some of you is probably pretty exciting. It has been a really big effort to get through all our trig equation stuff, and well done for hanging in there, particularly over online learning, where it's a bit harder to kind of ask those little questions about what on earth is going on, how these processes are working. So well done. Final little hurdle. We are asked to find the maximum and the minimum of a given wave function, which is here. Now, in an exam, you might be asked this slightly differently. You might be asked this as two parts of a question, but here I've just said by first writing it in the form y equals k cos x minus a. Now, I am going to cheat for the sake of not having a really, really long video. I am going to cheat a little bit and use the equation that we have used all the way through. So I'm going back and I'm saying, okay, well, first thing I'm going to do is put that in this form, k cos x minus a. Well, actually, as I say, I'm cheating. Here's our solution that we did in the first video on the wave equation. The very, very first video we did on the wave equation, we worked our way through and we turned minus 4 cos x plus 3 sine x into that form there. So this is a process that you have seen me do before, and for the sake of keeping videos succinct, I am using that previous result. If you can't remember how we get there, go back and check on that video. Okay, so that is our first part of our question, is taking this and turning it into that with all the working that goes in there. And so when you are doing your questions shortly, you will actually need to do that conversion process between one and the other. Next thing, we need to find the maximums and the minimums of this. Well, we've just been through a video on doing that. So first thing I'm going to do is I'm going to lay out cos x. Well, it has maximums. I might even make a wee table out of this. Maximums at 0, 1 and at 360, and it's got a minimum at 180 minus 1. Now we want to start transforming that, I should say. Well, this is 5 cos of something. And I realized I didn't actually mention in the previous video, when you are doing this, it doesn't matter whether you do the 5 or the plus or minus bit in the brackets first. It makes absolutely no difference in this case. What would make a difference is if you add something on the end. We would always do that last, kind of order of operation style. You do your multiplying factors first and then any adding factors afterwards. So keep your order of operations in mind. Here it doesn't matter which order you do them in. We can just do the transformations. So 5 there is scaling the y direction by 5. So 1 moves up to 5. And similarly with our 361. And our minimum, we're stretching the y coordinate by 5. So it goes from being at minus 1 to now being at minus 5. Let's build that up one last step. So here we are shifting the angle to x minus 143.1. Well, that, remember, if we're taking away, moves everything to the right. So we're adding 143.1 to each of our x coordinates. So our maximum here moves to 143.15. This one here moves to 403.15. And our minimum point moves to 323.1, comma, minus 5. Well, this one here has gone out of range because of everything we have done. So we can score that one out. And so our answer to our question is that's the maximum and this is the minimum. And we are finished. So it kind of is combining lots of processes that we have studied or just looked at recently. And hopefully that makes sense how we're kind of packaging those together to answer this very particular question. Great. You can have a little go at the questions, and then you can celebrate that you have finished everything trig equation and wave equation based. Well done.